So to solve an absolute value equation, you must first get the absolute value expression by itself. So let's pick another color because it's fun. Okay, so if I divide both sides by 6, the 6's cancel. And now this absolute value expression is isolated. It's all by itself. Oh, wait a minute. And that's actually -10, isn't it? Whoops. Okay. So now we can, because it's an equation, we will rewrite the equation twice. Once without the absolute value bars, and once where we change the sign of the right side, the side that doesn't have the absolute value. Okay. Now, at this point, we would typically, solve for x, because it might be like 2x plus 3 on the left side, but there's only just x, so it's done. Now, here's the kicker. Okay, so we have two solutions, but it's a good idea to check them and make sure they're actually working. Okay, now it turns out neither one of these solutions works. Okay, because once the absolute value expression was isolated right there, it said, hey, when is the absolute value of some number equal to a negative number? Well, that never happens. Absolute value makes things positive. That's just impossible. Doesn't make sense. And we could also check it on our calculator. So I'm going to go plug in the left side. Let's see, where are we at? Let me just pause this. And so the left side is 6 times math, right, 1 to get absolute value of x. And then the other side was -60. And then one thing we could do is go to the table and say, all right, if 10 or -10 is a solution, it's going to make the left side of the equation and the right side of the equation match up. So when x is -10, they do not match. And when x is +10, they do not match. And so that confirms that it's not a solution. Now, usually you do get a solution, but once the absolute value expression is isolated, if it's equal to a negative number, like it was on this one, then there's no solution. If it's equal to positive, then yeah, you're going to have a solution. All right, here's another one. I did skip some topics, but that's okay. This is about the hardest one, so that's something good. But we use the same rule we did on the last problem. We need to first get the absolute value expression by itself. So we got to move the 4 and the 36 away from it. Well, this problem is, to get the 4 and the 36 away, it's basically like saying 4x plus 36 equals 36. What would you do? Well, you'd first subtract away the 36, then you'd divide the 4 away. Well, that's what we're going to do. So I'll subtract away the 36 so that I get 4 times absolute value of 2x minus 2 is 0. And I'll divide both sides by 4. Let's see, 2x minus 2 in absolute value. Okay, now that the absolute value expression is by itself, I can rewrite the equation without the absolute value bars, and then rewrite it again, changing the sign of the right side. Well, 0 and -0 are the same thing, so I don't really have to do this because of the 0. So that's cool. So if I add 2 to both sides and then divide by 2, I get a single solution. Now let's I get x equals 1. So let's see how that looks on the calculator. And to do that, I'm going to plug that in for y1, plug that in for y2, and see what happens. And it looks like that. And I want to know where they're equal, where they match up. Well, I could go to the table and verify my solution. And look at that. When x is 1, the left and right sides match, and therefore x equals 1 is a solution. It's guaranteed. Okay, that's just all there is to it. Now, what if I want to explore that on the graph? So I could go zoom 6. I don't see anything, but that's okay because, well, y equals 36 is way off camera. That's a horizontal line at height 36, and then this is probably up there too. So an easy way to go find the stuff is to find the lines is to go zoom 0. And then there was that red line down there. So now let's go second trace 5, and then 3 enters. 1, 2, 3. And lo and behold, there it is, x equals 1. When it says intersection, I know that I have the intersection point, the solution to the equation. So x equals 1, that is a solution. I'm verifying it with the graph. Yeah, they intersect when x equals 1. And that is part of what we do. All right, let's do one more. What if you have two absolute value expressions? Well, we do the same thing. Step 1, get an absolute value expression by itself. Well, that's no problem because this guy already is by himself and so's that one. Okay, once that's done, step 2, write the equation twice. Once without the absolute values, and then another time changing the sign of the right side, of the entire right side. That's why I've got those parentheses there. Well, on the left equation, if we take away 4u from both sides, we're left with 7 equals 5. And again, this is not government accounting, so that's not true. So this stuff on the left does not yield a solution. It yields what's called a contradiction, something that's just never true. 7 is never equal to 5. So we see what happens on this right equation. So we'll do distribute that minus sign. And then I'll add 4u to both sides to get the u's together. This time the u's don't go away, so we're going to get an answer. Do a little takeaway. Oh, wait a minute. There's a mistake. There, that's better. And then when we divide by 8, we get negative 1.5. So there's only one solution, negative 1.5. Sometimes there's two solutions. Sometimes there's only one. Sometimes there's none. And that's how these types of problems are done.